Today I want to show two methods to calculate the cumulative sum. In this case I have months and money, and I want to calculate, well, how much money did I make in January? Then for February I want to see how much I made in February plus January, which means in August I want to sum the entire column. And to begin with, the wrong way to do it would be to try to use List.Sum directly and say, well, I want to sum up the list, which is then the money column, because when you refer to a column like this, it's accepted as if the column was a list, because a column is functionally a list, except it has a column header. And this, of course, gives an error, because when we add a column, we get this each keyword, which means that when I refer to the money column, I'm not referring to the entire column, I'm referring to the intersection between the entire column and the current row, which means this error message, we can't convert the value 7 to type list because the value 7 isn't a list. What will work is that I first want to extract the money column and then I can work with it afterwards. So I want to not go into added custom because this is a pointless step. It's just to show it. I want to go into the change type step, and then from this I want to extract the money column, which will give me a list. And because I'm going to refer to it multiple times, I want to wrap this in List.Buffer, which is going to load it into memory, which should be a lot faster. I'll refer to this list as many times as there are rows, so in this case 8. I then want to go back to my original table, the change type step, and from here I want to add a new column, which is an index, and I want this to start from 1, which will make sense in a moment. And this means that the custom 1 step is pointless, so I don't want to have that. It just makes it a bit easier to visualize, because trying to write code without seeing the table is a little annoying. What I then want to do is that there is a function that lets me go into a list and grab only X amount of rows. Well, in this case, it's going to be N amount of rows, conveniently called List.FirstN. So I want to go into my list, which is called load money as a list. So I do need to write it correctly. And the amount that I want to grab is then found within my index column. And here, the each keyword is then convenient because, again, this means in the first row, I grab the value 1, which means I have 1 item. In the second row, my index is 2, which means I grab 2 values. And now that I do have a list within the cell, when I then use custom function to say List.Sum, well, then I have a list found within the first n column, which will then give me what I expect. But of course, it's kind of pointless to add a new column and then add another new column when I can do it in one step. So I will grab this code. Actually, I want to grab that from here. These are just going to be there for visualization purposes. I can repeat this code. And then I want to say, instead of each List.FirstN, I want to wrap this then in List.Sum. And then sometimes it's nice and it understands indentation, and sometimes it doesn't. And now I do it in one step. And I then want to, just for illustration purposes, I want to filter it and only show those rows where I have below 60, so that I can find then the last row before I hit some threshold. Now that I have this, I want to add another column that I can use to filter, where I want to say that in this case, I only want to grab the value from first n if the value is below a threshold. Meaning I want to say if the value in first n is less than or equal to my max amount, which is just going to be 60, then I want to write the actual value, which is going to be first n. Otherwise, I want to write null, which means I can then add another step where I just filter out the nulls. And likewise, again, I can do this in one step, because my only point in adding this below threshold is to add a filter. I don't need to add a column just to add a filter. I can do that in one go. So if I go back to this, which was before I added my new column, and I can use the table select rows, and I'm acting upon this table, and actually I want indentation. Yeah, sometimes it's nice and sometimes it's not, and I can't really figure out why sometimes wants to give me indentation and sometimes not. So this is my table that I'm acting upon, and my condition is then that I only want to show those rows, meaning each, so I evaluate one row at a time, and I only want those where my first n column is less than or equal to 60, which will then filter it, so that's fine. And if I want to be a little more clever, then I can use a variable which I want to define outside of my function, because I'm only going to use it once, because I don't know exactly how Power Query handles these variables, and I worry that if I define it inside the function, then it's going to be recalculated for each row, which is pointless. but I can simply say let max amount be equal to, in this case, 60, and then in, so I can replace 60 with max amount. And because I define my variable outside of the inner function, this means I don't get this filter sign, but I can live with that. The trouble with this method is that I'm going to calculate the cumulative sum for each row, which is pointless when my output is that I want to filter. In this case, it would be better to make a function that will calculate the list sum, and then when I reach the end, well, then I know that I should stop. Because I could have 70,000 rows, and maybe I need to stop after only 2,000, and then I would end up calculating 68,000 more rows, which is completely pointless when I just filtered out. And this is why you should add filtering as early as possible to avoid calculating more values than you need. So to get started, I want to simply duplicate this because I want my original table. And actually, I still want my List.Buffer, then called source. And what I can do is use a function called List.Generate. What List.Generate does is it allows me to loop, and it can do something more complicated, like doing a calculation and then increasing my looper variable. It can do one calculation using my looper variable, and then it can add my looper variable. And then I can also add a condition telling when to stop. So in my case, I want to stop once my cumulative sum is greater than 60, or whatever you set the variable to. Which means I want to write List.Generate, and List.Generate takes initial as function, which might be very strange syntax, but what it means is basically what is my starting value, and I can't simply write 1. I need to provide a function. So I need to provide a function that results in the value 1. A function follows the syntax of open close parentheses, and then inside the parentheses you would add your variables, but I don't need any right now. Then you write the rocket ship operator, which is just equal to, then greater than. Then I write 1, because I want to start my loop in the first row of my money column list. Yeah, so I can say starting value is 1, i.e. first row. And my condition is then continue doing this list generate as long as this condition is met, which would be a do while loop. So in my case, I want to say that I want to keep going as long as my cumulative sum is less than or equal to 60. But I need to first calculate that. So I can say each list sum, because I need to calculate it for each row. I want to calculate the sum of a list. And what list is that? That is List.FirstN, which then I need to provide it with the list, which is called load money. And of course, that's not giving me a IntelliSense load money column. That is my list. And then my count or condition is then going to be the underscore. And the underscore is a bit tricky because it refers to the current value of my looper variable. And in my first row, I've defined it here to be equal to 1, which means when I'm in the first row, underscore will be 1, meaning that in the first row, I'm going to go into the list load money column, which is this list, and then I want to do a list.sum with a list that only has one value, which is 7. So the output of this function is going to be 7. And then I need to mind my parentheses. So now I'm saying list.sum, and my condition is then that I want this to be less than or equal to 60. And you could then create a variable up here. Actually, I should do that. Call let, and I keep wanting to write var. So let max value be equal to 60 in, and then I can say here. So now any user just has to go in and change this value. So as long as this condition is met, it's going to keep looping. My next function is then going to be, well, what is the value of my underscore going to be? And here I want to say, well, each, because for each row I need to do this calculation. And then I want to add a comment here that there's an implied underscore equals, because actually what you end up writing is each underscore plus 1 in my case, because I want to increment it by 1. So add 1 to my current looper. And the tricky part is that there's no assignment operator, which I think there's a programming language that does something like plus plus I or I plus plus, and it's the basic logic here. So I'm saying this is like I plus plus, I guess, except I'm saying plus 1. The second tricky thing about this next as function is that it doesn't say what is the current underscore, it's saying what is the next underscore. So up here, I say what is my starting value, then I say if this condition is met, then keep going. And then once I've decided to keep going, I have to decide what is the next value going to be. And only after I check that I do have to calculate for the current row, and after deciding what the next value should be, only then can I go to the next line? Actually, I need a comma here and say what is my selector. And selector is then going to be what I print, because I don't want to print the underscore. I actually want to copy all of this here and say that's what I actually want to print. So I need an enter here, and then I don't get that indentation. So this is my selector, which is then going to give me an error because I have parentheses. I need one more parentheses, which means instead of doing all of this, I can just copy it and then repeat it. But then here, instead of doing this list.sum, I want to instead say I want to call the function called local function. And then I don't get IntelliSense. Actually, I do. Oh, that's really nice. I didn't know that. That's great. It actually says that it wants me to pass in my var. And then if I delete this, then I don't need that either. And I don't need that either. Now I can do this. And likewise, I can do the exact same thing down below. So I don't want to say each list.sum. I can remove that. And then I need to mind my parentheses. Yeah, that's a lot cleaner to look at. And I want to see if when I try to call local function, if it understands that right here it's saying my var. And I want to see if I specify in here, I'm just saying my var, which means I could do this like my var as any, but specifically here it needs to be a number. So I could see as number. And now it says here my var as number. So I want to see if it then understands when I get that little pop-up, if it then gives me a bit more information, if it wants to pop up. It's being a little shy. Yeah, so it just says as number. I want to see if when I do this, if it then gives me the pop-up. No, it doesn't. Okay, that sucks, because I believe when you make the function a what I call a global function, which I'll also be showing, then the description you give it over here in properties, that will pop up when you show it. At least I believe it does. I can then say using local function. And of course, comparing these two, it's a lot apparent which method I prefer, which is the local function. Likewise, I can do this, but instead of having a step where I define a function, which is then kind of superfluous because I only use this in one step. So having a step dedicated to making a function that I use once is a bit unnecessary. So what I can do instead is to make the function inside of the step, which I'm going to do then. And I don't know what to call that. I think this would be a Lambda function in other programming languages. But if I just copy this part, because I do need the List.Generate portion, I'm not going to rewrite that. Instead of only having this max value variable, I want another variable, which is then going to be my function. So we'll just call it Lambda and say that this should be equal to a function that does take an argument called my var, and that goes towards, and then I can do this List.Sum, List.FirstN, which is then also always going to be the load money column, and then the amount I want to grab is my var, and I don't get IntelliSense here. Yeah, and then I can just say that this is Lambda function. And then I need a comma, because when you're doing this multiple steps, this is what I call an inner query. I'm saying let in, and if we go and check the code, you will get this, if I can find that. My actual query, so all of these steps are surrounded in this let in, where the last step is then Lambda function, because that's the last step over here. But then inside I have this let in, and I have let in, and then I have a comma here, meaning that these are two steps. So I could do this to make it a bit more apparent if someone were to go inside the advanced editor and check it, which I don't think anyone is going to do. And then inside of my List.Generate, I no longer want to call the local function. I now want to call the Lambda function. So instead of this, I want to say Lambda. And instead of this, I want to say Lambda. And it's the exact same output. The difference is that when you go inside the local function here, you're able to try it out. So you can write a number in and then call it, and then it gets mad. And this, I think, is caused because it's trying to call the function, but it can't actually, you can't, when you're in another query, you're not able to refer to specific steps inside of another query, which means that the invoked function tries to call cumsum-2, but that's the last step, and the last step doesn't take an argument because it's a table, and it's, well, actually it's a list, and you can't use a list as a function, which is what I'm trying to do, so this doesn't make sense. And that's one of the downsides of these inner queries and these local functions, is that you can't actually test this out anymore. Well, you could if you made a new step inside of this query where I have access to the local function, but I don't want to do that. So you can decide for yourself which method you think is easier. Personally, I would prefer doing this method, because then everything is stored where I need it, but it is definitely harder to troubleshoot. And lastly, I do want to create a global function, and I can actually just copy paste this because it's the function I want. And normally when you make a function, you're supposed to use parameters. And a downside is that when you are making a parameter, you can't pass in a list because a parameter is one value, which is either text or a number. And of course, this query doesn't work because it can't find the load money column, because that's a step inside of cumsum2. It's not a query in itself. So when I go in and I then call it, and then I need to copy this part. Actually, I should copy that one. And then instead of local, I can just say global. And instead of local, I say global. And the downside is here then that the function is going to break because it's saying here it can't find the load money column. So when I try to call the global function, it's just going to give me an error. The import load money column matches no exports. And that's because the load money column is found within my query. Meaning if I had a step where the last step was the load money column, then I could do it because then the function refers to a query. So I can actually do it if I just duplicated this and then delete all of these steps. And then I need to change the name because that's already used in a step. So if I change this to be cumsum3, which should be in quotation marks, then it's going to be fine. You can't use the global function if the function refers to a step that only exists within the local query, meaning that I can't make a global function that is a function that's actually a query in itself if that function needs to refer to a step that only exists within a query. But when I do it like this and I create a query that then has my list, then everything is fine. And in this case, I can do that, but I think that's kind of pointless because you end up with more queries. And as always, when you make functions, you generally should create parameters to test with. So I'm not following best practices. Now I can actually go back and do what I wanted to do from the beginning, which was to filter my change type step to only include those rows where the cumulative value in the money column is equal to or less than 60. And I can use any of these queries because they produce the same result. So I'm just going to continue from the global function. And what I want to do is to filter this to only include those rows before the cumulative value in the money column is greater than 60. And I can do that by taking the output of this query, and it doesn't matter which of the three I use. And I can simply say, well, this is a list, and I want to count how many there are. And conveniently, there's a function called that. So this will return 6, and I don't want this to be a step in itself because I only need it once, and it's kind of obvious what it does. So I want to say I want to grab the first n of my table, which is change type, and the amount I want is then this. And I should have done the indentation before. And again, the benefit here is that because I'm using this List.Generate, it stops once I hit the threshold and it doesn't continue. So I don't waste time calculating values I don't need. But if I then want to add my calculation, I would need to once again add my index from 1 because I can then pass that into any of the functions. In this case, I can just use the local function because that already exists. And here I also have two options. I can do what I just said and call the function. So say call the function. And this is going to be more expensive because I'm, using a function many times for each row, but I want to show it. So that was called local function. And that takes one argument, which is then my index column, which will then give me my number. And I can then say type number. But again, this is going to do one calculation for each row. And I've already done my calculation in any of these steps. So instead of calling my function, I instead want to go in and do a lookup. So what I can do is to say, I'm just going to say, use the local function because that's the one I actually use in this step. So I can say, I want to add a column where I want to go into the local function query. And then I want to return the value. And because this is a list, I don't have to specify the column. I do have to specify the position, which is going to be indexed. So I'm now doing a lookup into a list that has already been calculated. And I guess this then needs to be -1 because I'm actually getting more than I asked for. So I'm saying add a new column where I want to go into the using local function list and then return 1 for the first row and then 2 and so on. And I don't exactly know why I need to say -1 to the index. I'm guessing because this is then doing a lookup it's treating the list as if it's a table and tables start at index 0, or maybe it's just as with tables where the first row is index 0. So when I try to access the first row, I'm not getting the first row, I'm getting the second row because the second row is index 1. But in any case, this is the preferred method, and I don't want to add this new column to the calling function. I want to add that to the added index table because there's no point in calculating the same column twice, meaning that was everything I wanted to do. So yep,